Hey everyone, we are getting into our next unit, but before we actually start into the translating and solving process of our inequalities, we're going to revisit our proofs, well, our properties as proofs that we were given earlier this year. So this is why it's important to know those properties, because they come in looking a little bit different here. Actually, this is more in line with what your SOL is going to look like. So you're going to be responsible for taking those properties and applying them to a situation, okay? So what we're going to do is look at some order of operations and some equations, and we're going to justify the steps as we go through it using the properties that we know. Now, when you are given a problem, whether it's an order of ops problem or an equation, the first line is always going to say given. The reason for that is because they have to give you the problem to solve. So then what you're trying to do is you're trying to figure out what's going on from this step to this step. What has changed? So what I notice is 9 squared has become 81. Well, there's no property that says 9 squared is 81. What that is it's a math fact. And anytime that you have a math fact, you are substituting the answer for this problem. So what we would say is it's substitution, because we are substituting 81 where it used to be 9 squared. So we're going to call that substitution. Okay. Then I'm looking at what's happening next. What's happening next is I'm multiplying 1 over 81 times 81. This is like 81 over 1, okay? They are reciprocals of each other. So when you multiply reciprocals of each other, that would be your multiplicative inverse. From there, we are multiplying 2 times 1, because this information right here gives us this 1. Anything times 1 is itself. That's multiplicative identity. Okay, so now what we're doing is we're actually taking the properties and putting them into practice instead of just identifying them as an individual piece. All right, so let's move on to our next problem. Remember that first line, no matter what, is always given, because they have to give us a problem to solve. So that's going to never change. All right, so what do I notice happening here? I noticed that I had parentheses that were around this, and now the parentheses are here. Now there's not a change of order. If you notice, the numbers are in the same exact position, just the parentheses moved. That would be your associative property. All right, from there, what's happened? A -3 and a +3 were added together to give me 0. Anything plus its opposite equals 0 is additive inverse. All right, our next one, what's happened here is that we've taken our -2 plus 0 and got -2. Anything plus 0 is itself is additive identity. And then last but not least is -2 and +2 gave me 0. That is additive inverse. All right, so that's our second one. As we're moving through these problems, we're just justifying what steps allow these things to happen. All right, last one here. Remember that first line is given. And then we're trying to see what has happened, what's taken place here. Well, what I see is that this -45 divided by 3 has become -15. Again, that's a math fact. So we are just substituting this -15 in place of this math fact. So that is just substitution. Okay. From there, what's happened next? Well, +15 plus -15 is 0. That's additive inverse. Our next one is anything times 0 is 0. So that's the 0 property of multiplication. All right, next is 9 times 1 is 9. That's multiplicative identity. And last but not least, 0 plus 9 is 9. So anything plus 0 is itself is additive identity. So now all of these problems that we've done on the front are order of ops type problems. This can also apply to your equation problems as well. So let's go ahead and take a look at a couple of those. All right, notice that we have a two-step equation here, and we are saying that it's given because they gave us the equation to solve. All right, and then we're going to go through the solving process and justify our steps along the way. So on the first part, if you notice, we are doing subtracting 3 from both sides because we want these things to cancel out. All right, that is additive inverse because we're adding the opposite. Okay, and then on the next step, we are multiplying by the reciprocal of 1/2, which is 2 over 1. So when we multiply by the reciprocal, then that is your multiplicative inverse. And then last, we are taking this information and getting the answer 24. So anytime you're just getting that answer, that is a substitution because we're substituting this information with negative 24. So we have a substitution here. Okay, so that's really all there is with that one. That's kind of a short one. All right, and our last one for today, again, this is given because they gave us this equation to solve. Okay, so our first step is to take this 3 and distribute it through the set of parentheses. So that would be your distributive property. Okay, our next step is to add 6 to both sides to get rid of that negative 6. So we're adding the opposite. That would be your additive inverse. All right, our next step is to divide by 3. We're dividing by the coefficient here. With that one, we really, there is a property for that that's a little bit different, but for the most part, it is just, when you're dividing, it's a division property, even though we don't talk about it, but it's also multiplying by the reciprocal. So it doesn't look that way, but it is actually that way. So you're doing your multiplicative inverse here. And I know that sounds a little weird, but dividing by a coefficient is the same thing as multiplying by the reciprocal. So it's the multiplicative inverse. Okay, and then our last, and I have an extra line here. So what's happening here is we take negative 3 divided by 3 and get negative 1. That's a substitution. Okay, so those are your properties in action. That's really what it is that we're supposed to be doing with this year's properties instead of just naming the properties. If you have any questions, please feel free to reach out and ask, through email or during class or something. So we'll be working on your homework with this. And again, if you have any questions, please ask. Have a great day, everybody.